Okay, so actually I already cleaned the silicon wafer. This is my silicon wafer. What I did, I used the acetone at first. I used this acetone to clean the dirt from this silicon wafer. Then I used the IPA or isopropyl alcohol. Then I used the deionized water or DI water to remove the acetone and IPA from the surface of this silicon wafer. Okay, so you can see this is the silicon wafer. This is very shiny. This polished surface will be used mainly, and this surface is actually not smooth. So this is the back end, this is the front end. Okay, so after this cleaning process, there might be some water on top of the surface, and what we will do, we will use the air pressure to remove all the water droplets from the surface. I'm going to show you that now. So here we have air. I will start. We can hear some sound, and I can easily remove the water droplet using this air pressure. Now I will show you the spin coater machine. Okay, so this is the spin coater machine. I will remove the cover. This is the holder. Okay, there are different sizes of holders. Different sizes is used for different sizes of wafer. So I will place the silicon wafer on top of this holder, and actually it holds this wafer with vacuum pressure. Okay, we need to carefully place it in such a way that it is right at the middle of that holder. So I will turn on the power button, then I will turn on the vacuum pump. So it will make some sound. Let me tell you, I will turn on the vacuum pump. It will hold the silicon wafer, and you see the speed is already set here. So the final speed should be 2000 rpm. This is 200 here, 200 times 10, that is 2000 rpm for 30 seconds. What we do generally, we don't go to that high speed at once. We initiate the speed with some low speed like 30 times 10, 300 rpm for 10 seconds, then 2000 rpm for 30 seconds. So I will cover it with the lid, then I will turn on the vacuum pump, then I will start the spin coating. Okay, so before spin coating, we need to place the photoresist. Okay, we need to drop some amount of photoresist on top of the silicon wafer. Then that photoresist will be spin coated and it will be uniform. So we need uniform thickness, right? So let me show you. Here in this cabinet we have some chemicals. We have different types of photoresists. So for our today's demonstration, we will use this one, which is SQ10. So SQ10, I poured some amount of SQ10 on top of the silicon wafer. Then I will place the lid, the cover, then vacuum pump on and start. We can see the spinning of the silicon wafer. Okay, after the spin coating is done, we will see that I have already turned off the vacuum pump. So after that we will see that a uniform layer of photoresist has been deposited on top of the silicon wafer. Okay, next step is soft bake. Soft bake is done here. The temperature is initially 65 degrees Celsius. For 2 minutes. The temperature is now at 27. It will automatically go up to 65 degrees Celsius. Okay, so the temperature is set at 65 now, and I will use a stopwatch. It will be soft bake at 65 degrees Celsius for 2 minutes. So after 2 minutes, I will increase the temperature up to 95 degrees Celsius. And then we will hold it for 5 seconds. It will take some time to raise the temperature from 65 to 95. When it is at 95, after that we will wait for 5 minutes. So next step is photolithography. After the soft bake is done, we will take this silicon wafer and we'll come here. This is the microwriter machine. This is the software. I will press this button, and after a few seconds I can actually open this gate. I will place this silicon wafer. You see the flashing is off. Now I can take this, let me show you from here. I will open the gate and I will place this inside this chamber. So you see the silicon wafer is at the middle. Actually we can place larger size of wafers here also. After that I will press this button again. It will close this lid, and there is a Z direction stage which exposes the UV light that came into the right position. So after that I will come back to this computer, and here there are 3 steps. One is, you see my cursor here, align wafer, prepare pattern, and expose. So at first align wafer, I need to click here microscope and click here focus assist. So it will take a few seconds to focus the actual plane. I may need to input the wafer thickness here, so the input maybe 500 micron. The wafer thickness. This is the autofocus. I clicked here and I will wait for few seconds. So after focusing, we will say we'll see some black and white boxes like check box here. So it takes a few minutes generally to autofocus the actual surface where we are going to expose the UV light. After the focusing, we will go to this prepare pattern. We will add a job here, add a new job, click here, and we need to select the design, the pattern, okay? So maybe I will use this one. I have selected the file. It will take a few seconds to show it here. Now you can see the design. So the design is actually like this. There are some microstructures. These are 8 by 10 micron circles. So 8 is the diameter, the 10 is the distance between the circles. So after this step, we will go to the expose and we will write down the energy. So the photoresist sensitivity is in millijoule per centimeter square. So according to the guideline or the protocol of the photoresist, it's written 270 millijoule per centimeter square for our photoresist. So I have written 270 here, and this is the start exposure. I clicked here now, and then after clicking this exposure, it takes a few minutes or a few seconds to finish the photolithography. So the UV light will be exposed, and it will be exposed according to my design. Okay, so after a few seconds it has stopped exposing that UV light. So what I can do now, I can just open this lid. I click this button again, and then after a few seconds I will hear a click sound. Then I will be able to open this gate. There is a click sound. I can open the gate, and let me take that out. I closed it. So now this silicon wafer has been exposed to UV light according to my pattern. So I want to close this application, and I want to turn off this machine. So at first I need to close this application, close this software. So just close it, and after that I will turn off the switch. So now I will take this wafer again to the hot plate. So it will be baked now, which is called post-exposure bake. It will be baked now again for 2 minutes at 65 degrees Celsius and for 7 minutes at 95 degrees Celsius. So what I will do, I will just set the temperature and do the similar kind of things. So this baking is called post-exposure bake. After the post-exposure bake, we can take this silicon wafer, and what we will do, we will develop it. Okay, so develop is done with help of a developer. So developer, I'm not going to show that step because it takes a long time. So the develop is done in a bath, like maybe in this bowl, or we have some petri dishes. We will keep this silicon wafer there in that petri dish, and we will submerge it with the developer, and then we will rinse it, and we will actually shake this so that the developer can strip out the photoresist as per the design, as per the pattern. Okay, so after that development, we will again bake that on the hot plate. So that is known as hard bake. So after the hard bake, photolithography is done. Okay, now if someone wants to etch out the material like the silicon or silicon dioxide or maybe chromium or something like that, so they will use chromium etchant or silicon etchant or silicon dioxide etchant or etching agent or something like this. Okay, so this is photolithography. What we did first, we cleaned the silicon wafer, we cleaned it with acetone, we cleaned it with isopropyl alcohol, distilled water, we made it dry with help of pressurized air, then we did the spin coating of the silicon wafer with the photoresist, then soft bake, then photolithography, then post-exposure bake, then development, then hard bake, and that's it. So as I said before, in our lab we can do microfabrication, not nanofabrication. So this is a sample, or this is a microfluidic device. More precisely, I should say, this is a digital microfluidic device that we have made with the help of photolithography. So here you can see the pattern. This is actually a glass slide, and the black materials are actually chromium. Okay, so we designed a photo mask, or we designed the mask like this. Then we did the the UV exposure under the photolithography machine, and after the development we got something like this. So this is actually a digital microfluidic device. After this I will just add a video where I will show how I use this digital microfluidic device for transportation of water droplet from one area to another area. Okay, so that's it. Thank you all for watching this demonstration. Bye.